Oh, I can actually walk down this corner of the room. I got one big box out of here. Okay, so today, this is for Mr. D. And if I'm not mistaken, this might be a comeback. I don't know. As in, like, something went awry in shipping. I don't know. I think could be wrong. So today's game is What's Inside the Box, BBI. This is video number 2 of What's Inside the Box series. It's relatively light, I know that. So what do we have in here? What do we have in here? What do we have in here? I have some styrofoam. Hello, audio. Does that kill off the background noise when I take the foam and wrap it around the microphone? Yeah, okay. Let's see. What do we have? What do we have? It is a amplifier. No way. This isn't one of my cabinets. How are you? Little to no padding. Well, hell. Well, I had no idea. But today's mystery amplifier is yet another Worthmore style box. Let me call the customer and let's get into it. Deja vu. It's the exact same amp board that was on that last Worthmore we worked on just a couple days ago. I would say from this tape marking and this one that they're hooked up backwards, but after you sit there and you look at the circuit, I don't think there's really... We'll come back to that. This is the first one of these I've ever seen. This is a multi-band 8-pill Worthmore. And as we can clearly see, we've got the smoke has come out on this resistor and way come out on this resistor. He says he primarily uses this on 40. The last one that was here, I jumped into it just assuming that I knew, oh, it's just got the one bad transistor to it. And then after I got it all put together, come to find out, I had another one blown in another section. So what we're going to do is we're going to do what I call a bump test. We're going to hook it up, put power to it, put RF to it. We're going to key it up, and we're just going to quick key it, and we're going to watch with the FLIR to see which one of the transistors heats up. Also in that other amp, I ended up having some caps. It was a 4-pill unit. The output capacitors tested fine when you take them out, but then when you go to use them, I had one that was falling out, so it would cause the whole box to fall into resonance. Look at this. This is unsoldered too. It caused the box to fall into in resonance, or out of resonance. And so I ended up putting metal clads here and replacing the input capacitors. So let's do the bump test on it and make sure that all the transistors are working except for this one here. So it's, of course, right in the middle. So we get to go do heart surgery, but that's okay. That's okay. This is a quick, easy fix. Not a big deal. Just a couple resistors to change out and he'll be back out. Or a couple resistors and a few transistors to change and he'll be back running in just 2 seconds. So let's talk more do. Now, that being said, this control cable has to come over and plug into this control cable at the front. I don't want to show you the lid, the top of the lid, because it's got his contact information on it, but this control cable we're going to have to plug in over here. It's set up for the remote at the moment. And this is all hanging out nice and pretty with this cute little foam tape. God, the whole inside of this is covered with solder flake once again. I wonder if that was just his style of building. Doesn't matter. Okay, let's do the bump test on it and see what happens. You know, Mauser's usually pretty Johnny on the spot, but ordered these Friday, kind of late in the day though, like 2 o'clock in the afternoon Friday, and they just showed up. Today's Tuesday. So we're back on this Worthmore. Let's set this aside for now. And 80, 40, 20 right here. So move these out of the way. Well, let's take this band board out of here real quick and let's see what we got. This is a single-sided etched board. Ground trigger, input source, switch, shunt to ground. Trigger wire goes across. Disc capacitor for resonancy because it's passing in parallel with the conductor source. Trigger. Okay, so this is our trigger source, this blue wire. This wire is running in parallel with this wire, so to keep it from being a natural inductor, there's a disc capacitor here and a disc capacitor here. That trigger wire hooks up to that pin, which in turn drops the signal out here when it's switched. Here also switches from here to here. So I didn't need to take the board out at all. I could have fixed it in the cabinet, at least with this particular version. I've never taken one of these apart. Every one of these that have ever been in here worked till today. The only thing I would do differently if I was building this board myself is I'd make it so that these wires were secured somehow, so that the solder joint where the wires meet the board isn't taken to punishment. Actually, the jacketed portion of the wire is, but I digress. It doesn't really matter. All right, let's bust out the solder wick and let's take these two relays off. Yep. Okay, not this relay. Well, let's go use up another foot of solder wick and get this other relay off. Okay. Well, that relay also tested good. I don't really care. I'm just like, it's interesting. This is what handles output. So then I went along and I put the voltmeter across these two ports and then individually triggered each section. Now I don't know if the relay was frozen and me coming along and me desoldering the relay and moving it around was enough to get it to be unfrozen. But in the previous test, it was direct pass-through, no matter what I did on any band. So, I don't know. We're going to see what happens here. Let's clean all the flux off the board from our solder work. So we got a nice clean solder joint. I don't have to worry about this again in the future. Give it a quick douche here. No douche. Alright, get out the air compressor, we'll blow this off and then we'll put the new relays on it. We'll see. I mean, it could have been, the relay wasn't soldered on there square. Who knows? Okay, so this 10-meter band. So those are all doing their job. They're firing when they're supposed to. Let's see, what else can I do for a test? I know. Okay. So this is our network analyzer, and the way we're going to use it now is the same way that we would do with like a MFJ 259B. We're going to have it create a signal. Now what we're currently set up to do is read from 0 to 30 megahertz. Okay, let's zip on in here and let's take a closer look at this real quick. So right now we're scanning. This little unit is producing a signal and it's going and it's putting out maybe 100 milliwatts worth of energy, but it's scanning from 0 megahertz to 30 megahertz. Now over here we've got our spectrum analyzer, and we've set it to read from 0 to 30 megahertz. Now we've only got 31 dBs of attenuator, and I removed the 10 dB attenuator I have here at the input, and we're actually talking directly to it. So the RF comes out of the network analyzer, comes down to the band filter board, then goes directly out, goes up to the splitter, which knocks it down about 3.5 dBs each direction, and then it splits and it goes from here and then over to our oscope, which I've explained on camera many times. So right now the band selector board is off. Okay, let's explain to you what's going to happen. I'm going to reach down here and I'm going to manually activate. This is the 80 meter band. Okay, then 40, then 20, then what band did they randomly select for 20, 40, 15, and then 10? So ding, 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 ding. Okay, we're going to manually activate that. How it's going to show up that that's actually working is we're going to see a signal like this. Let me activate the 10 meter band or 11 meter band. Okay, and what we're seeing is that we're getting a signal spike that's going from 0 megahertz all the way to 30 megahertz and then stopping. And what we see here is our actual, this is what the band filter is passing through it at the moment. So let's go over here. And our lowest resonant point for this particular board, 16 megahertz. And there's also capacitance that's on the amplifier that allows us to match the input impedance for this. Okay, this is a notch filter. So how this works is when you're on the 80 meter band, nothing above it can go by. And then when you go to the 40 meter band, nothing above 40 can go by. And then 20, and then 15, and then whatever and whatever. That's how this works. So what we're seeing though, what this test is showing us, is signal is going in and coming out, and it's unimpeded. So let me go to the other end of the band. Let me activate the 80 meter band. I don't have a good connection here, someplace. There we go. So now we're on just the 80 meter band. You see how that's showing up? Just that quick little spike is in the 80 meter band. Bloop, bloop, bloop. And then it's not able to go any further. So we know 80 is working. So let's go look at 40. So we know the trap is working for the bottom one's 160, the next one up is 80. So we know we're working up to 80 meters. Now let's go hook up to 40. 40 is working. Let's go hook up to 20. 20 is working. Let's hook up to 15. 15 is working. And now 10 meters. So 10 is working. You know, I might have been fixated on the wrong thing. 160, 80, 40, and 20 was where we were having the problem, right? Not too far off, actually, but I digress. Filter board's working. All the relays are working. We can get signal to go in and come out. So I want to change these two relays. I do. I really do. I did, honestly, I thought, because 20 was where it was dead. So 160, 80, 40. I gotta change these relays out. That's all there is to it. I think we're actually getting someplace now here, guys. We got signal going through the filter, and now the filter is showing me what the problem is. See that black blurb in the back? So this is a 330 puff 5%, and this is a 330 puff 5%, and it's also got a hole in it. So if, I think we might have just cracked the code. This cap blew and it freaking took everything to ground, and when it did, it blew up the contacts in the relay. The cap reads 10.7 ohms. That could be a problem. Man, I don't know shit about Shinola, but that could be a problem. And this one reads 333 puff. And with that cap being open, that explains why our output resistors over here on the amplifier are smoked as hell. Cap got hot, cap overheated, cap failed. Took all RF to ground, and it blew up the relays. And that in turn shows a high input SWR in 20, and that's why this, and this are smoked. Oh, okay. All right, let me go get some new capacitors here. Okay. That 330 went bad, of course, and well, so what we replaced it with was some metal clads. So these will never fail. These caps here are, well, I would say at least 5 to 6 times stronger than any other cap on this board. These are set up for 1,000 volts. These are, or no, more than 1,000. How many kV are these metal clads that we use on these things, Zane? I don't remember off the top of my head. Oh, they're 500 volts, that's right. So 0.5 kV. The metal, not made out of this other shit. So anyhow, I took a 390, a 250, and a 65. So we're pretty close. We're within a couple puff. And boy, this thing works great now. But there's another problem yet. That now that we know that this is working, and we've got this working on all the bands now, and before something else decides to quit, I took it out of the lid because the lid was wrecking this remote wire, and it was causing everything to get smacked into too many times. So I took it out of the lid so I could fiddly fart around with it because it doesn't have anything to do with the operation. So here we are, we're on 40, as we can clearly see, and going to put ourselves a little bit of drive into it. Hello, 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 hello. About 100 watts. Hello, 1 2 1 2 1 2 1 2 1 2 1 2. Okay. Turn the peak kit off on this thing here. Here's our new presented problem. Let's see if we can put this in frame for you. That is the output combiner resistor for this 4-pill section. Hello, 1 2 1 2 1 2. That thing's smoking, and so's that thing. But this guy, sitting down here, is as cool as a cucumber. So this 4-pill section has no issues. That one does. Let's go figure out what cap or what's gone wrong back here now. Well, this is going to be an interesting amount of work. I get to take this whole thing apart because something is wrong in this back 2-pill section. These transistors are firing. These two are not even trying. And this one, the 15 ohmer, is getting hot, but then the flyback on this one's getting warm. It's like these aren't even turning on, they're just dragging. So based on the quality of the solder work at this end of the frickin' amplifier, this has been apart a couple times. So I'll pull all the caps out of it. This one, this one, this one, this one. We're going to pull the ground bar out. We'll take it apart. We're going to check every cap. We're going to look for something. There's something that's either dragging it to ground, or we got 2 blown pills, or 1 blown pill in the other. Normally you can see it with the FLIR one trying to fire, but it's like, doesn't want to do anything. I don't know. But we've obviously got a problem down here. This is the 15 ohmer that was turned brown, and then these resistors are screaming at me in every foreign language plus English saying there's a problem, stop. So when in doubt, whip it out, she says. All right, so I've pulled all the caps off that 1 2-pill section because we've got a problem. Ooh, 504. It's supposed to be a 500 puff. I don't want to just go in here and put new pills in this one section because 510, 506. These are the caps that go on the input. Let's look at our output caps, the ones that are the most prone to failure. Also 505. .502. This is supposedly a 250 puff electrolytic. This is what sits down next to the transformer. Oh, fell out. Okay. What we're hunting to see is if I've got a bad cap, because this section has been apart many times. You can tell just by looking at it that it's been apart 3 or 4 times. So all these caps check out, which is interesting. It's a 104. It's a 99. It's a lot of capacitance difference there. 106 nanofarad versus 99 nanofarad. It's a pretty wide variance. I might need to stick a new cap on that, but I don't see that the reason why this 2-pill section here is not firing. Well, let's pull the pill out and see if it's truly legitimately because it's got a bad pill in it or not. So this is interesting. The reason I pulled all the caps out of this is because the last one of these I worked on, it had a bad pill in it. I replaced the pill in one section. It was obviously fried. Then I went to another section, well, put it all back together and went to run it, and the front section had a bad pill in it. But the reason the front pill went bad was because it had a bad capacitor that was way out of value. Well, so I wanted to check all the caps before I went and I did this. So let's test these two transistors. Okay, that one's good with a gain of 36. Okay, this transistor is bad. So we have one dead transistor out of 8. That one's still good with a gain of 36. And while I'm here, I got to clean all of this up because there's bunches of little solder flick and smoo and shmoo and chew and boo and blah, blah, blah. We're on the tail end of this thing. Thank God. Okay, I think I got all the bugs worked out of it. So, make sure amp is on. We're an auto key up. So, make sure we get all this set up. Measuring devices are as follows: volt amps, 1,000 watt in peak, 1,000 in average, 5 watt slug in reverse. So first off, we're going to start off at the 160 meter mark, which this box really likes to work down low. Hello, I'm going to put about 85 in it. Hello, audio 1 2 1 2 1 2. If they cannot hear you, let me double check that, because you know what, I did leave my peak meter on last night. Hello, that's right. Okay. If they can't hear you on 900 watts on 160, and have a nice day. Okay. So now we've gone ahead and we've switched over here to 80 meters. We'll turn the amp off once again. Hello, 1 2 1 2 1 2. Okay. So we're putting into it for drive. Now, this is where this box starts to come into its own. Hello. That's well over 1,000 watts peak. Let's go ahead and we're going to go to the 2x settings. So that means this marker here, the big hash mark between the 40 and the 60 is 1,000. Hello. Making about 1250. 1250. Hello. Pulling about 150 amps. Okay, let's go to the problem child band. We're going to go to 40 meters now. Turn the amp off. Hello, 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 hello. Oh, now we're up on 2x. We're going to be back there again in a second. Hello, 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 hello. Turn the amp back on. Hello. Now, this was Mr. Moore's personal box, come to find out. So I'm literally getting to rebuild a piece of history here. Hello, 1 2 1 2. Oh, I flipped it to 5x, pardon me. Now let's go up to 2x again. Hello, 1 2 1 2. 1,200, 1,300 watts on 40. Now let's jump on up here to 20. 20. Once again, amp off. Hello, 1 2 1 2 1 2. Hello, 1 2 1 2 1 2. Good to go. Okay. Once again. Hello, 1 2. Now we're making 900 watts on 20, and we've gone up the curve, over the top. Now we're going to start going down. Hello, 1 2. So to make this component work, There's a curve that's on all amateur amplifiers. You can't make it work great on all bands. You can only make it work well on most. So there's a curve where the amp will come up into its resonant path and then it'll taper back off again. So we peaked at 40, so now we're going to head to 20. We just did 20. We're doing 900 watts. So now we're going to drop to 15. Let's go to 15 meters. Yeah, that's 15. All right, let's try this one more time. Amp off. Hello, 1, 2. We're still in 2X, dummy. No, I'm a 1X. Hello, 1, 2. Hello, 1, 2. That's odd. The radio's putting out half power. Oh well. Hello, 1, 2. I'm on AM, that's why. Ha! Durr. It's an ICOM. Hello, 1, 2. Okay. Hello, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2. I had it on 12 meters. My dumb ass. 15. Okay. Hello, 1, 2, 1, 2. 700 watts. Now let's go to the 10 meter position, otherwise known as aux. Sideband, full power. Amp off. Hello, 1, 2. Hello, 1, 2. 500 watts. Now there's one more modification I've got to do to this thing. There's just one more little thing I got to do to this before it can leave here. And the customer has made me swear to secrecy, so we're going to call it a win. Let's take a look at this. Let's take a look at that. The output resistor's at 100 degrees. A balancing resistor's at 100. That attenuator's at 106. And that one is at 99. It's in balance. It's all fixed. It makes power everywhere it should. Ha-cha-cha-cha. Okay, I'm going to put the tuning board back in the box, and now we're going to go totally fart around with the fans and see if we can get them to either move more air, or move more air. But there's a little modification I got to make to this that you all don't get to see because it's secret. It's secret. But we'll be back. We're finally at the end of this dog and pony show. Well, it's the OG Mr. Worthmore himself's box. Is now fully repaired, restored, and modified a little bit. And we got rid of them slow ass, don't move any fans, cause box to overheat and melt down. We turned it up a little bit. These are a little bit higher CFM fan. These are, I believe, some pathetic number. 0.6 of an amp. 0.16 of an amp, so 0.16 of an amp. These are quarter amp fans, but they're much more high volume, which will get you more air. I didn't want to get too aggressive. Like I got jet blowers that are the same size as these holes. You said this is in your Jeep. This will help a bunch. We're done. It come in here because it wouldn't work on 40. Now it works everywhere. Works everywhere. All right, gentlemen, on to the next one. My name's BBI. Big shout out to Siglent, MechMan, Excess Power, Bird, Coaxial Dynamics, and as always, thanks to my Patreons. Thanks to my Patreons. Come join us. Just come to BBIamps.com/Patreons and come find us. Come join us. Gentlemen, thank you. I'll see you. Bye.